In this video, I'll introduce the concept of a union of sets and the probability of such a union. While unification can in real life lead to an entity that gets new properties and is more than the sum of its parts, in set and probability theory that kind of magic doesn't exist. A union is simply the sum of the parts where special care is taken that things are not counted double. I will start with an example. You pick up 3 shells at random at the beach, and there are only 2 types of shell around, Q and R. The 2 shell types are equally abundant and innumerable. The sample space in this case comprises 8 outcomes. And the tree diagram for the entire experiment is shown here. The probability to get any combination of the 3 shells is 1/8. Let's consider the events of picking up 1 R shell in total, event A, versus picking up 2 R shells in total, event B. And let's assume that you would be interested in the combined event. Event A occurs, or event B occurs, or both A and B occur at the same time. The name for combining events in this way is a union. This is the shorthand for writing the union of events A and B. To calculate the probability of a union of event A and B, you have to sum the probability of both events and then subtract the probability for the intersection of A and B. The reason for subtracting the intersection in this calculation is because it would be counted double otherwise. After all, the intersection of A and B is part of A as well as B. So by summing the probabilities for A and B, this joint probability is effectively counted twice. The probability of picking up 1 R shell, event A, is 3/8, and the probability of picking up 2 R shells is the same. The sum of these is 6/8, which is 3/4. As it turns out, events A and B do not share any outcomes. They are disjoint. So the probability of their intersection is 0. And therefore, the probability of the union of A and B is just the sum of their separate probabilities, 3/4. Now consider 2 different events. C, the first shell you pick up would be an R shell, and D, the last shell you pick up is an R shell. Clearly, these 2 events are not disjoint because they overlap. The intersection of events C and D comprises the outcomes where the first shell you pick up is an R shell, and also the third shell you pick up is an R shell. There are 2 of these outcomes. In this case, the probability of the union of C and D is found by adding the probability of C to that of D and subtracting the intersection of C and D. The result of that turns out to be 3/4. At this point, I have a question for you. Could you tell the probability of the union of events A, B, C and D? If you apply the equation for union mechanically, it gets a little bit tedious as it requires a number of additions and subtractions. But since there are not that many elementary events in the total sample space, there's a simpler approach. You can list the 8 elementary events and just tick them off one by one if they occur in any of the 4 combined events. In the end, only the outcome where you pick up no R shells appears to be absent from the 4 combined events, while the other 7 outcomes are part of at least 1 combined event. So the probability of the union of these 4 events is 7/8. I hope you have learned the following from this video. The union of several events is an event that contains all the outcomes from the original events without duplication. The probability of the union of several events is the sum of the probabilities of the separate events minus the probability of the intersection among the events. For 2 events, the equation is shown here. If events are disjoint, the probability of intersection is 0, and the equation for union simplifies to only adding up the separate probabilities.